Welcome guys to another video. In this video, there will be a fast-paced review of how to find derivatives. So let's get right into this video. So for our first derivative, let's say we're asked to find the derivative of y equals sine of 4x. And we'll put this in parentheses. So let's say we're asked to find the derivative of that. What would this be? Take a moment to figure it out and unpause the video when you're done. So, assuming you did everything correctly, this would be cosine, and then we do g of x, which is 4x. Let me rewrite that. 4x times, and then we have to take the derivative of 4x, and that'd just be 4. And this would be equal to 4 cosine of 4x. So for our second derivative, let's say we're asked to find the derivative of y equals 1 minus x squared to the 10th. So take a moment to figure this out as well, and unpause the video when you're done. So assuming that you did it all correctly again, this would be 10 1 minus x squared to the 9th times, and we have to take the derivative of 1 minus x squared, and this would just be negative 2x. So this would be negative 20x 1 minus x squared to the 9th. So now let's go to another problem here. Similar concept. Let's say we're asked to find g of x equals x cubed plus 4x to the 7th. Take a moment to figure this one out as well, and when you're done, unpause the video and see if you got it correct. So same concept as this problem up here. This would just be 7x cubed plus 4x to the 6th times, and we just take the derivative of the inside. So the derivative of x cubed plus 4x is just 3x squared. Let's put this all in parentheses. 3x squared plus 4. And this would just be equal to 7 3x squared plus 4 times x cubed plus 4x to the 6th. Okay, for our next problem here, let's say we're asked to find the derivative of h of x is equal to root 4 1 plus 2x plus x cubed. So if we're asked to find the derivative of this, take a moment or two to figure this one out, and when you're ready, come back. So assuming that we did everything correctly, the first step to this problem would be to rewrite it. So this would just be h of x is equal to 1 plus 2x plus x cubed to the 1/4. And then here we can just apply the general power rule to this. So this would just be 1/4 1 plus 2x plus x cubed, and then it would be 1/4 minus 1, so that is just negative 1/4, and then times, and we take the derivative inside now, so that'd be 2 plus 3x squared. And we can actually simplify this as 2 plus 3x squared. Write that 2 plus 3x squared, 4, and then root 4. Let me rewrite that real quick. Root 4. Can I get this? Yes. Root 4. And this would just be 1 plus 2x plus x cubed, like that. And then let's say we have another problem here. We're asked to find g of t is equal to 1 over t fourth plus 1 cubed. Take a moment or two to figure this problem out, and when you're done, come back. So for this problem here, we can use the combination of the quotient rule and the general power rule. So let's do that real quick. So g prime of t is equal to, and then the quotient rule is low. So low t fourth plus 1 cubed, low d high, so the derivative of the high is just 0, and then minus high, and then d low. So now we have to take the derivative of the bottom, and the derivative of the bottom would just be 3 t fourth plus 1 squared times, and then we'd have to take the derivative of t fourth plus 1 now, and that would just be 4t cubed. And then the quotient rule states that everything is squared at the bottom, so then this would just be t fourth plus 1 cubed, but then times 2, so that's just 6. And then if we simplify all this, we get negative 3, or no, we get negative 12 t cubed t fourth plus 1 squared over t fourth plus 1 to the 6. And then of course we can just simplify this as negative 12 t cubed over t fourth plus 1 to the 4th. So let's try to do a few more problems here. So let's say that we're asked to find the derivative of y equals 2x minus 5th to the 4th, 8x squared minus 5 to the negative 3. So take a moment or two to figure this one out and come back when you're ready. So if you did this correctly, we could either use the quotient rule or the product rule to do this. In order to use the quotient rule, this is the same thing as having 8x squared minus 5 to the cubed in the denominator. But in this case, I think the product rule would probably be easier here because it would require a few less steps. So let's try that. Y prime is equal to, and then we take the first term, 2x minus 5 fourth, and multiply it by the derivative of the second term. So in this case, it would just be negative 3 8x squared minus 5 to the negative 4th times, and then it would be times the derivative of the inside, and the derivative of the inside is just 16x, and then plus, let's write this a little small so we can fit it all in, plus the second term, 8x squared minus 5 times the derivative of this, and this would just be 2x minus 5 to the third multiplied by the derivative of the inside, which is just times 2, like so. And then we can simplify this a bit to be 2x minus 5 times negative 48x to the 8x squared minus 5 plus 8x squared minus 5. Oh, and then I forgot this right here, but there's actually supposed to be a negative 3 right here, like that, because it's to the power right here. I forgot, my bad. So it would be 8x squared minus 5 to the negative 3. And then we can simplify this a bit as 8 2x minus 5 cubed, like so. And then we could simplify a bit more if we really wanted to, but on the AP test, they don't require you to simplify, and simplifying is honestly just more time for error. So in this case, we won't simplify because they won't require it on the AP test. So for our next problem here, let's say we're given h of z is equal, oops, that's wrong. H of z is equal to root z minus 1, z plus 1. Take a moment or two to figure this out, and when you're done, come back to the video. So in order to do this problem right here, what we'd have to do is find h prime of z. And we can actually, for this problem right here, this is the same thing as, let me just write it up here, z minus 1 to the 1/2, z plus 1 to the 1/2. And then in this case, it's most likely easier to just use the quotient rule. So let's use the quotient rule. Low z plus 1 to the 1/2. Low d high, so we'd have to find a derivative. 1/2 z minus 1 to the negative 1/2. And then this would just be times 1 minus high and then d low. So we just have to find the derivative of z plus 1 now. 1/2 z plus 1 negative 1/2. And then this would just be times 1 as well. So, like so. And then we have to divide this whole thing by z plus 1 squared, which is just z plus 1. Like so. And then again, we could simplify if we wanted to, but on the AP test, they're testing your calculus and not your simplification. So hence, there is really no need to simplify because that just leads to room for error. So this is our final answer. And then let's try a few more problems here. Let's say we're given y is equal to tangent of cosine of x, like so. Find what y prime is, and then come back when you're ready. So in order to solve this problem here, we can just use the we can just use the chain rule. So in order to find the chain rule, what we can do is we can take the derivative of tangent, and the derivative of tangent is just secant squared. So secant squared of cosine of x. And we have to find the derivative of the inside, which is cosine of x. So the derivative of cosine of x is just simply sine of x, or negative sine of x. So this just turns out to be negative sine of x secant squared cosine of x, like so. And then let's try a few more problems like this now. So let's say we're asked to find the derivative of y equals 1 plus cosine squared of x to the 6. So take a moment or two to figure this one out. And when you're ready, come back and see if you got the answer right. So in order to do this problem right here, what we have to do is use the general power rule. So in order to find it, use general power rule. So this is just 6 times y plus cosine squared of x to the 5th. And now we have to find the derivative of 1 plus cosine squared of x. So this is where it actually gets a little tricky. So let's do this in multiple steps. So now we're asked to find the derivative of cosine squared of x. So let's write that out. dx, or no, dx of, and we're asked to find the derivative of 1 plus cosine squared of x now. Like so. So it's always good to break these problems down into multiple steps so you don't make mistakes. So let's write it out. 1 plus cosine squared of x to the 5th, like so. And then let's find the derivative of this. So the derivative of 1 is just 0. But then the challenging part here is finding the derivative of cosine squared of x. So the derivative of cosine squared of x, well, first off, this can actually be rewritten as cosine of x squared, like so. So knowing that, we can use the general power rule, and this would just be 2 cosine of x to the power of 1, and we're asked to find the derivative of cosine of x now, and the derivative of cosine of x is just negative sine of x. So this will be equal to negative 12 sine of x. Yes, this would just be equal to negative 12 sine of x times 1 plus cosine squared of x to the 5th times cosine of x, like so. So this would be your answer. So let's try one more problem now to see if you truly understand this. So let's try to find the derivative of y is equal to sine tangent of root sine x, like so. So take a minute or two to figure this out, and when you're done, come back to the video and see if you were right. So I'm assuming that you tried the problem out for yourself, but if you didn't, this is a challenging problem, so here's how you would do it. So the first step here would be to take the chain rule and see what we get from there. So for the chain rule here, we would find the derivative of sine. That's just cosine. And then now we would write the inside layer. So tangent of root of sine of x, like so. And then now we have to find the derivative of the inside. So let's write that out. dx of tangent root sine of x. So then if we were to find that, it would be, let's write this. So in order to find the derivative tangent of sine of x, because this is the same thing as tangent of sine of x if you didn't know. So we'd have to use the chain rule again. So we have to find the derivative of tangent, and the derivative of tangent is just secant squared of x. So secant squared, and then we'd write the inside, root sine of x, and then now we'd have to find the derivative of root sine x. So let's write that in, dx root sine of x, like so. And now let's write it all of this again. So cosine tangent root sine of x, secant squared root sine of x times ddx of root sine of x. So this is actually the same thing as sine of x to the 1/2. So knowing this, we can just use the general power rule. So let's do that real quick. So the general power rule is 1/2 sine of x to negative 1/2, and then we have to do the derivative of sine of x now. So the derivative of sine of x is just cosine of x, like so. And if you simplify all of this together, it would just be equal to cosine tangent root sine x times secant squared of root sine x times cosine x. All this is over 2 root sine of x, because this translates right here to 1 over 2 root sine of x. So if this helps you out, or you got some practice from this, please subscribe to the channel and like the video and comment what you need help on below. And if you really didn't understand this or you need extra practice, I have a Calculus AB playlist up that has derivative rules and implicit rates and everything you need. So if you like this, please subscribe, and I'll see you guys in the next one.